Good morning, all of you. So if you notice it, presently we are studying effects of redox reactions in everyday life, correct? That is what we can say natural redox reactions. So in last class I taught you, so one of the most useful redox reaction in our everyday life, that is what we studied, respiration. Is it yes? So now, and also I told you the next one which is having disadvantage, that is what corrosion. So corrosion of metals, or we can say corrosion. So now today we are going to study what is the preventive methods of this corrosion or rusting. Okay, means how we can prevent prevention of corrosion, and later we are going to study the last respiration redox reaction in our daily life. That is what we used to call as rancidity. So now what is rancidity and how to prevent prevention of rancidity we will study. So this corrosion and rancidity is a disadvantage of redox reactions in everyday life, and respiration is the one redox reaction which is having useful for our everyday life. So now if it comes to here, so as we know corrosion, so what do you mean by corrosion? Simply I can say that corrosion means what? Just spoiling or eating up of metals by the reaction of some atmospheric gases. Is it yes or no? So or else spoiling of metals we can say simply, or else destruction of metals by reaction of some atmospheric gases like oxygen, carbon dioxide, water vapor, and what is that?
Sulfur dioxide.
Sulfur dioxide, or we can say compounds of sulfur. So compounds of sulfur. So that is what we used to call as corrosion. So if you notice it in this corrosion, so if iron metal is reacting with atmosphere and if it is spoiling, then we can say iron alone, what we used to call? Iron alone we used to call as rusting, or we can say rusting of iron. So in last class, totally 4 metals I taught you. So if you take iron, so iron if it will react with atmospheric gases, carbon dioxide and water vapor, so it will react, what it will form guys? It will form iron oxide. Is it yes? So iron oxide, that is what it is hydrated. So we can represent with, it will represent with how? Fe2O3 dot XH2. So X indicate number of water molecules. That is what I said. So this is hydrated iron oxide. Is it yes or no? Hydrated iron oxide. So that is the first thing. Now if you notice it, after this copper metal, after that I told you what? Silver metal. So these all 3 metals, if you notice it, they will be completely damaged. Completely, understand? They will be destruction, or they will be eaten up by the reaction of atmospheric gases. But if you take it, 2 metals which I taught you, what is the 2 metals guys?
Aluminium, zinc.
Aluminium, zinc.
Yeah, aluminum and zinc, if you take it, these metals, see for these metals, what is that? Iron, copper and silver, always some protection is needed. We have to protect them. But if you take aluminum and zinc, for this one, protection is not needed. Why means? These metals also will get corrode, but only the upper layer of this aluminum zinc will get corrode. Later they will form unreactive oxide. What is that guys? A inert layer or protective layer of oxide. So that is what we used to say what? Inert layer. So inert means which will not react further. So a inert layer of oxides it will form. That is what we can say aluminum oxide, or it will form zinc oxide. Yes or no? So now, so it will prevent further passing of atmospheric gases into inside of metal, so that no corrosion will be carried out further. So that is why for this aluminum and zinc, protection is not needed anymore. And we can use this one even in preventing corrosion of other metals also. So that is what we'll study now. So because once the top layer of aluminum and zinc will react, it will form a protective layer of aluminum oxide or zinc oxide, which is completely inert layer. Understand? So what is the inert layer? What do you mean by this? What is the use of this? So once it will form the top layer, no further, like it will work like a barricade. It won't allow the oxygen gas to go inside the metal further. So if there is no oxygen gas is passing, is it possible to take place the corrosion?
No, sir.
No, that is what you have to remember, because a required condition for further taking place of corrosion is oxygen. Oxygen need to supply from the atmosphere. So once oxygen is not supplying from atmosphere, no corrosion will be takes place. So this is all what we studied in the last class. Is it right? Yeah. Now if it comes to here in our today's class, directly we'll go. That is what prevention of rusting, or we can say prevention methods of corrosion. So please all of you keep reading and you can write it. Shall I say? So now if you notice it, this corrosion or rusting. So because of that, metal strength will be strong or it will become weak, guys, because of corrosion. Anybody? Weak. So,
sir.
because of corrosion, it will weakens the strength of the metal. That is what you have to remember. So everywhere you can notice it, even the railings, car bodies, bridges, ships, and all the things, etc., all you can notice it. A lot of every year, I told you, hundreds of millions of kg of iron is going to be corroded and is going to be getting lost because of this corrosion only. So this rusting or corrosion weakens the strength of all kind of iron manufactured or steel manufactured bridges, everything steel objects such as a bridge, iron railings, and all the automobiles. Even you can see like protection gates, entry gates, and all everything. So that is why we can say this corrosion is a which process? Oxidation or reduction? This corrosion is a oxidation process. Yes or no? So actually it is a redox reaction. So oxidation of iron or oxidation of other metal, it will be what is happening? A strong iron body, if it will be getting corrosion, it will be turns into what? It will be turns into a soft, porous. What do you mean by porous, Elmokil? Porous and
holes.
Yeah, porous means
holes.
like a hole. Understanding? Small holes it will be having. So powdery substance. So it will turns into a soft, porous and powdery substance. So that is only we used to call it as. What we used to call, guys? Called as rust, we can say, or we can say corrosion. So every metal, once it will be corrosion is taking place, then it will be weakened. It will become weak. Or else it will weaken the strength of the metals. That is what you have to remember. So that is why we must know how to protect it. That is what we are going to study. Prevention of rusting, or we can say prevention of corrosion. Okay, so you can keep reading prevention of corrosion. So now, as I taught you, what is the required conditions for corrosion of iron or rusting of iron? Anybody? Corrosion of iron or
oxygen and water.
Oxygen and water, as well as
Carbon dioxide.
Yes or no? If we take copper, what is the required conditions? Carbon dioxide, oxygen,
carbon dioxide,
Oxygen, water.
If we take silver, what is the required conditions? Hydrogen sulfide.
sulfur compounds.
Yeah, hydrogen sulfide. That is what sulfur compound. So, suppose if I want to prevent the iron from the rusting, then I can cut the oxygen and I can cut the supply of hydrogen or water, so that automatically the corrosion won't be takes place. Yes or no? Yes. And if you want to save the copper metal, if I'll stop the carbon dioxide or oxygen or water vapor, automatically prevention will stop. The corrosion will be won't be takes place further. Is it yes or no?
Yes, sir.
Yes, that is what you have to remember. So now if you'll notice it, then what is happening here? So what is the prevention of corrosion? The first method is, so you remember when you are protecting the metals. So if you'll notice it, the necessary requirement of rusting is two things. So what is the necessary requirement of corrosion? What is the necessary requirement of corrosion or rusting? So the necessary requirements is oxygen and moisture. Yes or no? Requirements for corrosion is oxygen and moisture, or else you can take carbon dioxide also, and moisture mainly. So now if you take this one, or we can take H2S. So now we can like whatever it is we are doing the preventive methods, once if will prevent this moisture, oxygen, carbon dioxide, then automatically the corrosion will stop. Is it yes or no, guys? Yes,
Yes,
or
sir.
no? So once it will stop meeting these metals with this oxygen and carbon dioxide, moisture and H2S, then automatically the prevention, the corrosion will be automatically controlled. So that is why what is the first method which we have to do means, so the surface of metal objects, always we have to do oiling. What do we have to do, guys?
Oiling.
Greasing. That is the first preventive method. So greasing, you all know about the grease. Grease, you know, guys, black color or brown color it will be there. Yes, please
Yes, sir.
respond. Yes. So if you take any kind of metal, the surface of metal, we have to treat it with what? Surface of metal object, understand, is coated with oil, grease, or any kind of paints. So that is the reason always metal surfaces we are painting. Have you noticed it? Yes, please respond.
Yes, sir.
Yes, that is what. So that is what. So if you notice it, so everywhere it is, you can see all the metal surfaces we are applying the paint. Why? So paints, what they will do? So the paints, they will prevent the supplying of oxygen or water vapor or carbon dioxide or hydrogen sulfide based upon the metals. So that is why I will say you, Kevin Prakash, you listen. So that is what we can say. So oiling or greasing, and even you can say and painting also. So painting the surfaces of metals, so it will prevent the supply of oxygen and moisture, so that it will be automatically prevented. So that is the first technique. Next, second method is electroplating. What is that, guys? Electroplating. Okay. See, remember, these all the techniques majorly we will use. You can see most of the rail casings and etc. If you take car bodies, bridges and all, it is an iron mixture. Yes or no, guys? Iron is the major metal. So this all the techniques majorly we will use it for prevention of iron only, means rusting of iron. So that is what we can say. So electroplating means, remember, electroplating means with the help of electricity, understand? So if you take iron piece, this is what we used to say iron. What we used to call this one, guys? Iron, understanding? So now what we will do means a thin layer of chromium and nickel, we will make it like we'll be electroplating with the help of a molten. For example, let me imagine this is the piece of iron. I am drawing, all of you observe. So this is the piece of iron. So now what we will do means on the surface of this one, all the surfaces, complete surfaces will be coated with the help of molten chromium and nickel will be coated with the what? Like a liquid chromium and nickel mixture will be coated on the surface of iron, so that no corrosion will be takes place. So iron will be preventing from the corrosion or rusting. That is what you have to remember. So iron is electroplated. So electroplated is the technique where we will melt iron and nickel and chromium, and will with the help of electricity we will apply the coating. So that is what we can say. That is so electroplated with understanding corrosion resistant metal, such that what is that metal, guys? Such as chromium, nickel. So they are having very less corrosion. They are having more corrosive resistance. So that is what we will do. Is it okay, guys? They will sir, the nickel will not get rust. They will get rust, but only the less percentage. It's not like iron. Understand? Iron is the most corrosive metal. Even copper also less corrosive metal. That is why we will take all these preventive methods. Majorly, we will use it for iron, because iron is the one where majority of the articles means like rail casings, all the car bodies, ships, and every other things, everything we are making with the iron only. So that is why we will apply this all the methods for prevention of rusting, or we can say commonly prevention of corrosion. Is it okay? So that is what you have to remember. So in electroplating, what is the metals we are using? Electroplatings we are using the metals such as high corrosive resistant metals, that is chromium and nickel. So this is the second preventive methods of rusting. Next, the third one is, as Kevin Prakash said, third one is galvanization. What is this, guys? Galvanization. So galvanization means immediately your mind should remember we are coating the surface of iron with a molten zinc. What is that, guys? Molten zinc. So what do you mean by molten zinc? It means we'll melt the zinc. We'll melt the zinc metal and coating the surface of iron. Understanding? Surface of iron. So that what is happening, guys? Anybody can tell me? If you coat the molten zinc on surface of iron, what is happening? So zinc will react with oxygen and it will form what? A zinc oxide. Yes or no? So a zinc oxide is a protective layer so that no further corrosion will be takes place. Is it yes or no? Please respond, everybody. So if you take it. So now we will coat molten zinc will be coated on the surrounding of iron so that these will react with oxygen. So it will form what? This zinc metal will react with oxygen. It will form zinc oxide. So this zinc oxide is a what? Inert layer. Understanding, everybody? So inert layer. So this zinc oxide, once it will form, it won't allow the oxygen to go inside. So no further supply of oxygen, so that iron will be protected from the corrosion. Is it okay, guys? Everybody? That is what you have to remember. So galvanization, what we are using? It is the process of coating the iron surface with a thin layer of zinc. That is what we can say to prevent the rusting of iron. So we can say here, we will take here is a molten zinc. Molten zinc we will say. So this is only we can say it is zinc is nothing, Durga. So we will take zinc metal, we will melt it. Understanding? We will melt it means molten zinc. So now that zinc we will apply the coating on the surface of iron. So this box is iron, imagine. So on the top layers, all the top layers, we will coat with the zinc. Understand? So this zinc metal will react with oxygen and it will form zinc oxide. So this zinc oxide is the inert layer, or it is the protective layer. So it won't allow the oxygen to move further inside the iron. So iron will never get oxygen supply. So if there is no supply of oxygen as well as moisture, so then what is happening? Iron will never get corrosion. That's all. So that is what we used to say galvanization. So now, why sir here we are using galvanization like zinc metal? Actually, zinc is the more electropositive metal. What is that, guys? More
Electropositive.
You understand it? So that it will react much faster with oxygen and it will form very fastly a protective layer called as zinc oxide. Is it okay, guys? Is it okay, all of you understand? Sir, what is electropositive? I told you, reactivity nature. If we'll say metal activity series, can anybody say metal activity series? Please, metal activity series. Potassium,
Potassium, sodium, calcium.
aluminum. Please never call me a zebra. Zinc, I like. Have you noticed it? Who is more electropositive? Who is more reactive? Who is more reactive? Zinc is more reactive. Iron. So this zinc will react with oxygen. Fastly it will form zinc oxide. Same way, aluminum will react with oxygen. Fastly it will form what? Aluminum oxide. So these one, they won't allow further moving off, further supply of oxygen plus water moisture to the iron, so that iron will be always protected. Is it okay, guys? Please respond. That is what you have to remember. Okay. So that is what. Next. After this, then we are going to studying with the next preventive method. That is what we are going to study. Tinning. What is that?
Tinning.
Tinning. So tinning means again same thing. We are coating with a tin. What is this? We are coating with what? Coating with a tin. For what? Coating with a tin on the surface of iron. On the surface of iron, so that it is protecting from the corrosion. Sir, how sir tin will protect the corrosion of iron? Because tin is less electropositive than iron. What is that? Less electropositive than iron, so that it won't react much with the oxygen and as well as water vapor. So that is what we can say. So tin also, a protective layer of tin also will protect the iron from the corrosion or rusting of iron. Why? So please never call me a zebra. I means what? Iron. Like means what, guys? Lead. Yes or no? So lead after only. So I like hydrogen we are getting. Is it yes or no? Please respond. I like hydrogen we are getting, but basically hydrogen before one metal will come. That metal only we used to call it as Sn. Sn means what, guys? Sn means what? Tin. Okay. So that is what you have to remember. But original metal activity series, no tin is mentioned, but tin is less reactive than iron and more reactive than what? More reactive than hydrogen. So for your purpose, I am saying, so that you have to remember. So after lead, tin will come. Only very few metal activity series only they will mention. So but you have to remember. So that is what. So it is less electropositive in nature. So that is why it will protect the iron from the corrosion. So this is what tinning. Any doubt, guys? Please respond. So how many methods now over? One is oiling, greasing and painting. First one. Second one is electroplating. Third one is galvanization. And fourth one is what? Tinning. Now, next if we'll take it. So one more method it is there. If we'll apply the aluminum coating, then we used to call it as the name it is something it is there. If we'll apply aluminum protective layer. So okay. So now corrosion of iron if we'll take. So these are the methods we can use it for corrosion of iron. So next one is called as the last method which we can use it called as alloying. What is that, guys? Alloying. So alloying means you all people know. Can anybody tell me what do you mean by alloying? What is alloying?
Mixture of iron.
Yes?
Coating of iron with aluminum.
No. Alloying means
Mixture of iron.
mixture of metals. Do you understand? So mixture, alloy means it is a mixture. Means iron is mixed with the other metals. Mixed with the other metals, so that even though it is a mixture, it won't be behaves like iron, so that it is always protecting from the protecting from the corrosion. So that is what you have to remember. So the last one is alloying. So iron is alloyed with the, basically alloying means mixed with the other metals. So basically iron with alloyed, understanding. So iron is alloyed with nickel or chromium. What is that? Nickel or chromium, so that it will be preventing corrosion. So that is what you can say. It will be preventing from the corrosion, because prevention from corrosion. So because why, what is happening when the iron, when it is in alloying state, when it is in mixed with other metals, so it is very less reactive. Do you understand, everybody? When iron is alone is present, then we can say it is what, more reactive. But the same one which is reacting with which is mixed with other metals, then it will be behaves like a less reactive. So that is what it will be preventing. So these are the methods which we can prevent the corrosion. So till here, any doubt, anybody can ask me, please. So this is what 5 methods you can write, all of you. Any doubt?
No, sir.
Yeah.
Sir.
Yeah.
Sir, it is, sir, when we mix with nickel and or chromium, it will become less reactive, sir.
It will become
Sir, less reactive.
less reactive, because it will become alloy. So if you will make a mixture, you will make a mixture with a certain percentage, that is iron will be some percentage, nickel will be some percentage, and as well as chromium will be some percentage. Then 3 together we used to call it as a that material. So that iron, it lost its properties of corrosion and it behaves like a less reactive method. Okay, that is what it is. Clear?
Sir, okay, sir. But when it will corrode, sir?
It will corrode in the sense of, it will be like a very slow process. So it will take more years to corrode. That is what we can say. Okay. It will be corrosion, but it will be very less percentage, in the sense of like maximum it won't be corroded when it is mixed with other metals. That is what we are using alloys, like alternative method for iron. Instead of iron, we are using these alloys. So that, for example, you can take steel. You can see steel is mixed with some kind of manganese, nickel, chromium and all. So steel is very less corroded compared to the other iron it will take. Do you understand?
Okay, sir.
Yeah. Is it completed? Everybody?
Yes, sir.
Yeah.
Yes, sir.
Okay, sir.
Yes, sir. Now, if you take it. Yeah. So now if you take this one, so this is all about the preventive methods of iron, or prevention methods of rusting of iron, we can say, or corrosion of iron. So now if you take the last redox reaction, which we are going to study in our daily life, so that is what it is, rancidity. So rancidity is not the new phenomena. It is a very common phenomena which we used to observe in our daily life. Minal, what you are asking, oxidation and reduction, once again, I will explain you, Minal, don't worry. So now if you notice it, so last one is called as rancidity. So now rancidity is the common phenomena which we used to observe in our daily life. So now if you take rancidity, so how many of you are eating chips? You are all eating chips. I am not asking computer chip. Normally potato chips and all you people are eating. Are you eating potato chips?
Yes, sir.
Please respond. So you might be eating the potato chips.
Yes,
You
sir.
might be see, sometimes if you keep it outside for a forget, suppose tonight 1 hour complete night you kept the chips outside and you forgot, you might be noticing that same chips if you try to eat, the chips, the surface of the chips, it will be turns into a light reddish color, and it will be, the taste also will change. Have you noticed it? Taste will change. Please respond. Yes. That is what it is called as. So if we'll take here, this is the biggest problem for our food items. That is what we can say. Is like we can say corrosion of food items when it is exposed to the atmosphere. That is what we used to call as. It is rancidity. Do you understand it? So now this rancidity is the biggest problem created by natural redox reactions. So here what is happening means some kind of food items, it's not all, which is containing oils and fats. What is that? Food items which contains what? Oils and fats alone. Do you understand? Oils and fats. So they will give the bad smell. The food items which contains oils and fats will give you what? Bad smell when they get exposed to the air for a long period of time. So that bad smell, how it is giving bad smell, guys? Anybody can tell me? So the bad smell is coming when a food items which is prepared with the oils and fats, like any kind of, you can see like different kind of items will prepare with oils and fats, correct? So all these things, when they react, when they are exposed to the atmosphere for a long period of time, understand? So for a long time, they will start producing the bad smell. So this bad smell only developing because of the formation of certain organic compounds when they will react with the atmospheric gases. So that is what we are used to called as rancidity. So once again, I'm saying, observe very carefully. If you take any kind of food items, which is prepared with what, guys? Which is prepared with what? Which is
Oil and fat.
prepared with the oils and fats. Which is prepared with the oils and fats. So these food items, when they will expose to atmosphere means without protecting, then what is happening? They will start giving which smell? They will give bad smell. You understanding, everybody? They will start giving bad smell. So which is actually indicating that some compounds are developing on the surface of the things. So that compounds only we used to call as some organic compounds. Understand? So because of formation of some organic compounds is called as rancidity. So this rancidity, it is taking place because of oxidation, means it will start reacting with the oxygen which is present in atmosphere. So atmosphere oxygen, so that it will start forming the organic compounds. So what do you mean by this means? So these oils, these oils and fats. So this contains what? These oils and fats basically made up of carbon, oxygen, and hydrogen. Do you understand it? So this is only majorly they contain. So that is why it is taking place naturally. That is why what we used to call as this one, natural oxidation process. Okay. So this natural oxidation of oils and fats, which will prevent in food items, and they will start giving bad smell, and as well as taste will change. Taste also will change, and as well as they will give you what? Bad smell they will produce once they will start reacting with the oxygen. So that is what you have to remember. But it's not all the food items. Which items? The food items which is prepared with what? Oils and fats only. Do you understand? So that they will react with oxygen. So oxidation process will take place. So oxidation process will take place means, you can see, if you are having potato chips in our home, just keep it for tonight, one day, and you can see next day if you try to eat the chips, you can see then a brown color coating is present on the surface of chips, brown color coating, and as well as a different smell is coming. And or else you can see, if you go to the shop, are you purchasing the any kind of different kind of kurkure or chips which is leak, like a package is damaged? Are you purchasing that? Once the package is damaged, Are you purchasing the chips or any kind of kurkures and all? Once the package is leaked,
sir.
or purchase, why you are not purchasing? Why it is not purchasing? Anybody? Because if you take it, so inside it will be filled with some kind of understanding gases. So these gases, they won't allow the oxidation process, so that smell and taste won't change. But if it is packet is damaged, what is happening? Then outside air will flow inside, so that which process will take place? Oxidation process will be carried out. So they will become, the crispiness also will gone, and also the reaction will take place, so that it is giving bad smell. Also, it will, the taste will change. So that is the reason always we will never buy which is the damaged packets of any kind of food items, like which is prepared with the fat and oils. That is what you have to remember. So these substances, they will form due to the oxidation only. So whatever it is forming, the taste is changing or bad smell is changing, both are causing of formation of new substances. What is the new substances they are? That is only they are organic compounds we used to call it as. So this formation of organic compounds will lead to the bad smell and taste. So this is taking place because of oxidation process. Because of which process? Because of oxidation process. So this oxidation is taking place from the air. So oxidation means what, guys? What do you mean by oxidation? Anybody? Addition of oxygen. Is it yes or no? Addition of oxygen we used to call it as oxidation. So this addition of oxygen is taking place from whom? Who is supplying oxygen? Pradosh, Monish? Who is supplying oxygen? From air it is coming.
Atmosphere.
That is why this is called as aerial oxidation. What we used to call, guys? Aerial oxidation. Do you understanding, everybody? So it is taking place from oxygen. Oxygen is coming from atmospheric air. That is why this process of oxidation we used to call as aerial